In this video, we're going to learn about the key facts to do with vectors. To start with, we need to know what a vector is. So basically, you can think of a vector as being a line that goes from the origin to a point. So the origin is the point 0, 0. So this point here, this word here, origin, is this point here, the point 0, 0. And it goes to a certain point up here, and we're going to call that point A. So this point here, A at the end, is where we're getting to, and this from 0 to A is the vector, so getting from one point to another. Now you don't always have to start at the origin when we're looking at vectors. We're just looking at this initial vector between 0 and A, which is written OA, and we need to use capital letters at the end of the line. So when we've got a line from here to here, we always use capital letters at the end. And 0 to A with this arrow over the top shows me I start at the point 0, which is this point here, and I go to point A. So that's what this vector means. When we're looking inside the line, so in this middle section here, small letters are used in the middle of the vector, and we can write this with A with a little line underneath, a little squiggle underneath. And that is what is represented in the middle of this line. So you can use the capital letters and we can use the little letters to explain what is going on. Now when you write it, you need to write in your exam a little a with a little squiggle underneath. Okay, but when you look in the exam paper, they won't have the squiggle in the exam paper because they will write it in bold. So if it's written in bold, okay, this capital A, this little a here is written in bold, it means it is a vector. So if you're looking in a book, your exam paper, or you're looking online or looking on a computer, it won't be underlined most of the time because they will do it in bold. The reason it's done in bold is because it is much quicker to type this one letter in bold than putting this little squiggle underneath. So when you're writing, you need to put the squiggles in, but when you see it on the computer, you won't have the squiggles. So throughout this video, sometimes there'll be the little squiggle there, and sometimes I will do it in bold. It's easier for me to do it in bold than putting the squiggle underneath, but in the exam, you must remember to do the squiggle. Now, every vector will have an arrow on them. And if there is no arrow, you will have to draw the arrows in to see what is going on. Now, the arrow indicates the direction of the vector, so which way you are going. So if I started at point here, point 0 here, or point O, and I'm going to point A, I'm going from 0 to A, so this arrow indicates I start at point 0 and I go up to point A. Now, all vectors have got a direction and a magnitude. Now, this is a key fact, but if you see vectors in maths or in physics and they just ask you generally about a vector, probably more so in physics than in maths, they will ask you what it means, and it has a direction and a magnitude. Now, the direction you can see is put in here by the arrow. This is the direction of it. The magnitude just means it has a size. So you can work out the length from 0 to A. So that's all the word magnitude means. So the magnitude of OA is the distance from 0 to A. So from here to here, the length of this line. And it can be written OA with the arrow above the top with two lines on the side. And these two lines either side here mean the magnitude. Now, as you go on to do higher level maths, you will find that this notation here means other things in higher level maths, such as modulus, but the vectors, when you see this symbol here, it means the magnitude and it means the length of the line between 0 and A. And you can use that shorthand notation in your exam. Now, all vectors are written in two different notations, and it is personal preference as to which notation you prefer to use. Now, vectors are written in I and J notation, or they're written in column vector notation. It is personal preference as to which one you use, and if the question gives it in terms of I and J, you must give your answer in terms of I and J, and if the question is in terms of a column vector, you give your answer in terms of a column vector. So you need to know what these means and how to flip between the two. So if I'm in terms of I and J, you can basically think of I as being your x-axis and the J as being your y-axis. This does go further into 3D, so we can have I, J, and then K in 3D, or we can have X, Y, and Z if you're in 3D for your x-axis. So we're looking here just in 2D, so I've got I and a J. So this is like my x-axis and my y-axis. And then if I've got a column vector, we use a big bracket, and the x value goes at the top, so that's how far you go across this way in the x-axis, and the y value goes underneath, and this is how far you go in your y-axis, which is up and down. Now, a common mistake is that people try and put a fraction line in between these two, because that's what you're used to doing when you have one number on top of the other. You always have a fraction line in between there. There is no fraction line between a vector, so it's just two numbers, one above the other, no fraction line in the middle, and brackets. Now, looking at this vector here I've got from 0 to a, say the distance along the bottom is 3, and the vertical distance is 2. So if I look going across, this is my x-axis, or in this case here, my y-axis. So I've gone 3 across to the right, which is a plus 3, which is 3 lots of I. Then going up 2, I've got plus 2j. Now, if I went to the right, it would be a negative, and if I went down, it would be a negative as well. So going to the left is a negative I, and going down is a negative j. So I can write this vector here that I've got from 0 to a as 3i plus 2j. So that is the vector from O to a is 3i plus 2j. Then if I write it in column vector notation, we just have the 3 at the top because that's the x value and the 2 underneath because that's the y value. Now we're going to look at the magnitude of the vector. So this vector we looked at earlier is the vector from 0 to a, which was 3 across in the x-axis and 2 up in the y-axis. And to find the length of this line here, from here to here, we're going to use Pythagoras' theorem, because having this x distance across here and this y value creates a right-angled triangle here, which means we can use Pythagoras' theorem. Remember, Pythagoras' theorem says x squared plus y squared is equal to c squared, or a squared plus b squared equals c squared. But in this case, a and b are x and y. So I've got a horizontal distance and a vertical distance. So when we're looking at coordinate axis to do Pythagoras, we're using an x value and a y value. Now remember, the formula is a squared plus b squared equals c squared. So to work out the value on its own, we have to square root. So this is going straight into the overall formula, so you can do it in one step on your calculator. So you've got the square root of x squared plus y squared will give you the length of OA. If you want to work them out separately, working out the value of x squared plus the value of y squared, add them together, then square root, then it will give you exactly the same answer. It's personal preference how you do it. So in this case here, I'm going to work out the magnitude of OA, which is going to be 3 squared plus 2 squared. We know 3 squared is 3 times 3, which is 9. 2 squared is 2 times 2, which is 4. 9 plus 4 is 13. So you can leave it in third form, which is root 13. Or if you go onto your calculator and type in root 13, press equals, you will get a decimal answer of 3.6 to 1 decimal place. So that is how you work out the length of the line at 0 to a. Parallel vectors are vectors that are multiple of each other. So for example, the vector that you can see here, a same vector as we've had before, from O to A, if I multiply the vector by 2, this vector becomes twice as long. Now, it doesn't always have to start at the origin. It can start at any point and go to any point. So it doesn't matter where it is. Any vector that is parallel to the vector that has been given, it can't go through the point 0, 0, as this initial vector went through, because otherwise it won't be parallel. So it has to go through 2 different other vectors at each end. And this vector here is now twice as long as the initial vector here. So this one is 2 lots of A, and this one is A. If I multiply the vector by -1, it means the vector changes direction. So instead of going between 0 and A, I'm now going from this top point up here down to the bottom point here on the left. So I'm now going from 2 different points. So the -A means I go the opposite direction to what I was going initially. Now, if I multiply a vector by a scalar, the word scalar means any number. So this scalar here, k, okay, is any number. So if I take the original vector that we were looking at before, 3i plus 2j, remember when you write it down, you have to put squiggles underneath. When we multiply by k, it means we're going to expand the brackets. So we're going to do k times by 3i, which is going to give me 3ki, plus k times by 2j, which is going to give me 2kj. So this is it written in vector notation, in I and j notation. Remember, put squiggles underneath your i's and j's. When we do it in column notation, I've got k times by a, where a was the vector 3, 2. So k times by 3 is 3k, and k times by 2 is 2k. So this is how we multiply by a scalar in terms of vectors. So we can do it in both types of notation. Adding vectors, we're going to start off with the vector from O to A again, which went across 3, 2. And when we add vectors, we're going to add the same components. And what that means is we add the I components together and we add the J components together. So if I've got my vector OA, which is the vector 3i plus 2j, or written as 3, 2, and I've got a new vector, which is OB, which is just a vector of j, which means 0 across in the x-axis and 1 up in the y-axis. So O to B starts at the point 0 and it goes up 1. Now we've already looked at parallel vectors, so we know parallel vectors are exactly the same, but they just moved in a different place. So if I've got a vector that goes from here O up to this point here B, okay, that is going to be this vector here O to B. Now if I take a point up here C, okay, and we're going to work out the distance from O to C. Now the point C, okay, is going to be at the point here if I've added a B on at this point here. So this is right at the top. So from O to C, if I go along from O to A, and then I add on B, takes me to the point C. Now remember I said O to B is this point here, from here upwards by 1 unit, but vectors which are parallel to each other, they can just shift over. So if this is up 1 unit here, if I come up 1 unit here, this distance here is B, because it is parallel to the original vector here, which went up a distance of B. And that will take me to the point C, which is where I'm trying to get to. I'm going to work out the length OC. So OC is this vector here. So to work out the vector O to C, I start at the point O, and I'm going to come across A, and then I'm going to go up B. Now ultimately I want to do this diagonal going from the O to C. That's the shortcut. But we don't know any distances on the shortcut, so we have to go round the houses in order to get to the point C. So as we can't go straight up here, we have to go across to A and then up to B. So we have to do, to get from O to C, we have to do O to A plus O to B. Now O to A is little a and O to B is little b. But we know the value of O to A, which is 3, 2 or 3i plus 2j. Again, remember the squiggles under the i's and j's. And the vector B is j or 0, 1. So if I do it in terms of I and j notation first, A is 3i plus 2j, which is what is written up here. And B is 1j. That gets written here. Now I've got 3i plus 2j plus j. So we just need to simplify. 2j plus j is going to give me 3j. So I've got 3i plus 3j. So to get from the point 0 up to here is 3 across and 3 up, which you can see from the diagram makes sense. If I do it in column vector notation, I've got the point 3, 2 for the point A and the point 0, 1 for the point B. I'm just going to add the top numbers, or the numbers at the top. So 3 plus 0 is 3. Then I'm going to add the numbers at the bottom. 2 plus 1 is also 3. So I've got 3, 3 for my vector 0C. So to get from 0 up to C, I've got the vector 3, 3. Now this forms something called the parallelogram rule. Now as I explained to you earlier, this vector here at this point here, B was this point up here. So B was this point here. Now if I go across doing A plus B, okay, I could do the same, go in the opposite way. I could do B plus A. Now we know addition is commutative, means it doesn't matter the order you add in. So if I do A plus B, it's the same as doing B plus A. So because A plus B, so A plus B is the same as B plus A, you can see I formed a parallelogram, which is why it's the parallelogram rule. Again, in physics, you will come across this rule, especially if you go on to do A-level physics, you will come across the parallelogram rule. We're now going to look at subtracting vectors. Again, we're going to start off with the same vector from O to A. And this time we're going to subtract the components. So we're going to subtract the I components, or the X distance, from each other, and then do the same in the J components or in the Y axis. So again, OA is exactly the same, 3, 2, and the vector OB is 0, 1. This time we're going to work out the vector from A to B. So this is going to help us subtract. Now, vector B is 0 across and 1 up. So 0 in the x-axis and 1 up, that's what 1j means, going up here with 1 unit in the y-axis. So we're going from A to B. So the distance here from A going to point B is what we've got to find. So we're going to find the length A to B. Now, again, we can't get directly from A to B because we don't know any measurements. We've got to work it out in terms of this little a and this little b here. So we have to go around the houses again. So we start at the point A because our line starts at A going to B. So we start at point A and we're going to come down here. Now, you'll notice when we come down here to the point O, we've gone against the arrow, which is why it's really important to put the arrows on your diagram. So we're not going the direction of the arrow anymore, which means we've got a subtract in there. So instead of this being plus A, if I go from 0 to A, this is a plus A, but if I go from A to 0, this becomes a minus A. And then I've got to come up this direction, which is going with the arrow, which is plus the B. So to get from A to B, it is A to O plus O to B, which is going to be negative A plus B. Now, in general, if you're going from A to B, you are going to always do OB minus OA. And this is a formula that will work for any single case. So it's really important you write it down and highlight this formula here because it will work for any given scenario. B is the first thing that comes here, so it's the second letter here is always the first thing that comes here, and the first letter here comes second. So it's always OB minus OA. Now we know OB is little b. Again, remember when you write this, you put squiggles underneath the vectors, and OA is little a. Now we know OB was the little b, which is just j, and minus a is going to be minus 3i plus 2j. Now here we've got to expand the brackets. Now there's nothing in front of this minus or after this minus here, so it's like there's a minus 1 in here. So we've got minus 1 times 3 to do, which is going to give you minus 3i, and minus 1 times 2, which is going to give you minus 2j. So that's how we expand the brackets here. So it's really important you remember this minus here. So it is very easy to forget that minus and just do it for the first term and not for the second one. We now need to combine the j terms because there are two j terms. So I'm going to have a minus 3i, and then I've got a j, take away 2j. So 1 take away 2 is negative 2. Is negative 1, sorry. So I've got minus 3i, take away j. Again, remember to put the squiggles underneath when you're writing. When it's written in column notation, you'll find we've got 0, 1, take away 3, 2. So we've got 0 take away 3, which is negative 3, and 1 take away 2 is negative 1. It is much easier to work in column notation than it is to work in the I and J notation because you're less likely to forget about this subtract when you are using the column notation. So I would recommend using column notation. I much prefer using this notation to the I's and J's, but just look at your question, and if your question is in terms of I's and J's, your answer needs to be in terms of I's and J's. So just make sure you've checked the question carefully as to what notation they are using. So that is how we subtract vectors. This question is on vector proof. A question that students find very difficult doing proof, but actually the principle behind it, if you can get to the answer, you guaranteed you're getting the marks if you know how to do proof. And it is something that students find difficult, but if you follow the key steps that I'm going to show you here, you're guaranteed to be able to get the full marks on this in the exam. And this question would be typically worth about 5 marks in the exam. So they can be pretty heavily weighted. You need to know what to do. So our key facts that we're looking at today are the word vector proof. So this is a vector question. You can see it's a vector question because we've got these little squiggles under the vectors from O to X. And it's a proof question because it's got the word prove in it. So we're going to look at the key bits of information in the question. So X is the midpoint of O to C. So from O to C, we have got X here in the middle. It's exactly in the middle. So X is here. All these bits of information here are actually included on this diagram. So you don't need to worry too much about it, but you do need to know that this point here is exactly in the middle because you'll have to know what the distances are. So it's really important we know the distance. The other bit of information up here, OXY is a triangle. You can see that in the diagram. You don't need to have that written down to know it as a triangle. You can see that that is a triangle. B is the midpoint of XY. Again, we need to know this is exactly in the middle. So between Y and X, B sits exactly in the middle. So the distance from Y to B is the same as the distance from B to X. You're told A is a point on the line OY. Again, you can see this from the diagram. You can see my point A is here. You're told that the distance O to X, so O to X is equal to little a, O to A, so O to A is equivalent to 2B, A to Y is equal to B, and you've got to prove that the points A, B and C, so A, B, C, all form a straight line. That's what you're asked to do. So pause the video, copy out the diagram for me. Okay. Once you've copied out the diagram, we're going to add on the key bits of information, and I'm going to give you some key facts to have a go at answering the question. If you think you could do the question without listening to the key facts, crack on, have a go at answering it, see if you can prove that ABC is a straight line. If you need a little bit more hints, then just keep listening and I'll show you what to do. So our key facts. We need to know that prove or proof basically means you've got to show this sentence at the bottom is correct. So this sentence down here, you must show that it is correct. And if you can do that, you've got the answer. So you're guaranteed you're going to get the marks in the exam. The word midpoint means the point in the middle. So X is in the middle between O and C, and B is in the middle between Y and X. And to find the midpoint, if you add both the points together, so the total distance, and divide it by 2, that gives you the midpoint. To prove all points lie on a straight line, you need to use a common point. So the common point could be the point A, the point B, or the point C, and I'm going to use A as my common point. So I'm going to look at the distance from A to B, and then I'm going to also look at the distance from A to C. So we have to include a common point when we're looking at proving this is a straight line, because if I looked at the distance from A to B and the distance from B to C, it could, if you get that they're a multiple of each other, then it just shows that they're parallel to each other. It doesn't show they're exactly the same straight line. Whereas if it goes through the same point, this point here, A, you're now taking these parallel lines and putting them on top of each other because it has a common point. So if we could show that A to B, the distance from here to here, is equal to K lots of A to C, so some multiple of A to C, where K is a scalar, it proves that ABC is a straight line. So if we work out these values of A to B, and the distance from A to C, then if they're a multiple of each other, which means the numbers or letters afterwards are in a multiple of each other, then you have answered the question. So here's my line ABC, and we've got to prove it. So we're looking at using this sentence I've got here, AB is equal to K lots of AC. That's what we need to show, and that will get us the marks in the exam. Press pause, have a go at working out the answer, and then press play when you're ready to hear the answer. So great work. So hopefully you've had a go at trying to work this out yourselves. If you don't know where to start, don't worry. I'll show you what to do. So to start with, we're going to write down the bits of information from the question. So you're told O to X is equal to A. So we just put an arrow on here showing we're going from O to X. This direction is equivalent to A. And O to A is 2B, so starting at O going to A is 2B, so we need the arrow going this direction. And going from A to Y is equal to B, so moving from A to Y, we've got a distance of B here. So this is what you're told in the question. So always write that information down on the diagram in the exam paper or what you've written down in front of you. Now we need to get cracking with finding out what A to B is. So A to B is this line here, from here, this green line that's just appeared from A to B. So to get from A to B, we can go the shortest route, which is the green route here, but we don't know any information about A to B by doing that. So we can go round the houses. Now it's personal preference whether you go round this way or you go round this way. So if you look where the cursor's pointed, so I could go from A to O to X and then to B, or I could start at A and I could come out to Y and then go to B. It doesn't matter which route you go. But if you go this top route, you can see I've got to do 1, 2, 3 lines. Whereas if I go down below, I've only got 2 lines to go. So we're going to go down. So I've got A to Y plus Y to B. So we write down A to B is A to Y plus Y to B. We know A to Y is little b. So our answer is always going to be in terms of these little letters here, A's and B's. So little y, AY is little b. And to get from Y to B is halfway between Y to X. So that's the midpoint of Y to, X is Y to B. So this point here. So we've got half of Y to X. So we're now going to look at working out what the distance is from Y to X. So this line here, Y to X. So we've got to start here. So we've got to go round the houses because we don't know the distance from Y to X. So we've got to go this way. So I've got to go from Y to O plus O to X. So going from Y to O plus O to X. Now Y to O, if you look at the arrows, we're going against the arrows. So this is, instead of being a plus B, becomes a minus B, minus a 2B, plus an A, going from O to X. You could write that as minus 3B. I'm just going to keep it separate to start with so you can see where it's coming from. So it's this minus B minus the 2B. So I've got a minus B minus 2B plus the A. So then I can substitute this into this equation here. So I've got A to B is B plus a half lots of minus B minus 2B plus A. If you want to simplify this together to be minus 3A, that's absolutely minus 3B, that's fine. I'm just going to leave it like this because it cancels nicely in a minute by leaving it in this form here separate. So I'm now going to expand the bracket. So I've got a half times by minus B, which is going to be negative B. I've got a half times by minus 2B, which is going to be negative B. And I've got a half times by A, which is going to be positive a half A. So just from expanding the bracket, multiplying all 3 terms in this bracket by a half. Okay, you could have left it as minus 3B over 2, or you've got minus a half B minus B, which is exactly the same. Now the reason I didn't multiply or connect these terms together is because I've got a plus B here and I've got a minus B. So this term here and this term here cancel, leaving me with the minus a half B plus the half A. I'm going to write the positive term first. So I've got a half A minus a half B. From here you can see both of these terms have got a factor of a half common. So half is going to come out the front of the brackets. We're factorising. If I take a half out the front, I'm left with an A minus B in the bracket. So we've worked out the left-hand side of this expression here, A to B. So we're expecting this term on the right-hand side, KAC, is going to be A minus B times by some number. So if I get AC to be some number times by A minus B, I have shown that this is a multiple of this because they've both got an A minus B in it. Okay, that's what I'm looking to find. So we've got to work out A to C. So A to C is from here, up here at A, all the way across to C. So we're going to go round the houses. We have to go this top route because going down the bottom bit is just pointless. We're just going to go up from A to O plus O to C. So to get from A to C, it was A to O plus O to C. Now A to O, we're heading against the arrow this time. So this is against the arrow, so this is a plus b if I went from O to A, but if I go from A to O, it's a minus 2b. This distance across the top is an A, but this distance here has got nothing written in. But we know that x is the midpoint of O to C. So if the distance from O to x is A, then this distance from x to C is also A. So starting at the point A, I've got a minus 2b plus an A plus an A. So to get from A to C is minus 2b plus A plus A. I can combine these two A terms together to give me A plus A is 2A. Take away the 2b, just writing the positive term first. Again, you can see I've got a factor of 2 common. So I can factorise again, taking the 2 outside the front of the bracket, leaving with 2 bracket A minus B. You can see here, these two terms here after the brackets are exactly the same, which is what we were hoping to find. So these bits here, the A minus B, are the same. Now, because A minus B is the same in both AB and AC, that means these two terms are parallel. But as A is a common point, it means they are exactly the same line. Therefore, AB is going to be some multiple of AC, which proves that ABC is in a straight line. Now, when it comes to the exam, you must write a little sentence or a little paragraph to explain your findings. So on any proof question, you must say you have proved the question. So you must state what you have found. So this proves that ABC is a straight line. You have to state that what you have found is proof that ABC is a straight line. If you miss this sentence off at the end on any proof question, you will lose 1 mark. So as I said, this question was probably worth about 5 marks in the exam, and this statement here at the bottom on any proof question will give you 1 mark. So this will be the final mark on the question. Give yourself a big tick if you got that correct. Well done, great work. Hopefully you managed to find this okay, and the explanation showing you how to find the ABC is a straight line been helpful. Please comment below if you have found it useful, and let me know your thoughts. Thank you very much.